and a gathering of civil enthusiasts and professionals. So, the main aim of Megalith is to encourage innovative ideas through various events, workshops, and seminars. Megalith, since its inception since 2009, has been a huge success. And almost every year, it's been a huge success. And from this year, we are back again with the 16th edition of Megalith. Today, we are here to witness the discussion about shaping a sustainable tomorrow, the much anticipated panel discussion on sustainable origins, where we embark on a journey of discovery and discourse at the intersection of innovation and environment consciousness. So, esteemed guests and distinguished experts joined us as we explore the frontiers of sustainability. So, the evening promises an enlightening exchange of ideas. My name is Gnaneshwar. I'm a core team of Megalith 2024, and along with me is
Ma-
Ishika. She's a core team
I'm
member of Megalith
Yashika and I'm
2024.
also a core team member of Megalith 2024. And we are immensely pleased to be the host for this session. Now, we would like to introduce the panelists we are having today. So we have Dr. Sudha Goel. She is from the Department of Civil Engineering at Indian Institute of Technology, Kharagpur. She specializes in environmental engineering. She is with profound expertise in environmental impact and risk management assessment, water quality and treatment.
Coming to our second panelist, we have Dr. Sudipta Sarkar. He is from the Department of Civil Engineering from Indian Institute of Technology, Roorkee. He is working in the fields of wastewater treatment, grey water reuse, solid waste management, and removal of trace contaminants.
Next we have Dr. A K Keshari. He is from the Department of Civil Engineering at Indian Institute of Technology, Delhi. He is an expert in hydrological modeling, sustainable development, waste management, sewage system, policy analysis, risk assessment, and snow or avalanche research.
We are also pleased to have Dr. Rajasekhar Balasubramanian with us today, demonstrating his commitment to this session by generously sparing his time. We appreciate his valuable contribution alongside our esteemed panelists. He is from the Department of Civil and Environmental Engineering at National University of Singapore. Being a distinguished researcher, his expertise includes environmental sustainability, climate change, and urban air quality. He is also notably recognized by the United Nations for his contribution.
Now that we have had a glimpse into the professor's expertise, let's dive right into the questionnaire. So, Sudha ma'am, we know that you have made significant contribution in your fields of interest. So, we would like to glad if you could briefly introduce your research areas.
Okay. Can you hear me?
Yes, ma'am.
Hello? Yeah.
Yes, ma'am.
Okay.
Yes.
Thank you for inviting me. It's a pleasure to be part of Megalith. It's been going on for a long time, and I've been able to interact with the students during this time. So each and every time, it's quite an interesting experience. Let me say a little bit about my research. One of my major areas of research is water quality and treatment. We have been looking at mainly the impact of chlorination on water quality. So, what is the level of disinfection byproducts in water that are formed after you chlorinate the water? That is one aspect. We also look at the microbial water quality. So, those are the two things that we have been looking at. And then the bulk of my research work has focused more on solid and hazardous waste management. So we have looked at municipal solid waste, electronic waste, we have looked at fly ash, we have looked at agricultural waste, the potential for deriving energy from agricultural waste, We are also looking at biodegradation of different organic fractions of municipal waste. So we've been doing a lot of things with different aspects. The last few students have been working on microplastics. So microplastics come mainly from solid waste. So they come from municipal solid waste, and you can also find them in consumer products. So one of the biggest challenges today, and in fact where you see a sort of interaction between solid waste and risk assessment, because these microplastics have become all pervasive. They are there everywhere in the environment. And like I said, they are in the consumer products as well as in the waste of whatever is generated in the homes and so on. And they will have an impact on human health as well as the ecosystem. So we are looking at all these aspects. Okay. So I won't go too far. I'll leave it at that. Thank you.
Thank you, ma'am. Thank you for sharing. And before proceeding further, may I request the panelists to please put their videos on? Thank you, panelists. So now turning to Dr. Sudipta Sarkar. Sir, could you please tell us about your field of study and the specific research domains you are engaged in?
Okay. Am I audible?
Yes, sir, you're audible.
Yeah. Um, Good afternoon, everybody. It's my pleasure to be here. So my area of work is broadly on environmental engineering, but I want to emphasize on one particular aspect is to how to recover values from the waste that we generate. So that's the central theme of my work, and with this, I try to venture into areas like solid waste management, water and wastewater treatment mainly, as well as air pollution and climate change. So just to elaborate a little bit, as you know, that solid waste generated from different resources, such as industrial resources as well as municipal domestic sources, they have got some value, but at the same time, you can see that wastewater also has some nutrients as well as some calorific value. And also, if you look at uh, when we talk about climate change and global, warming, and trying to pinpoint that carbon dioxide as to be the villain, there is an opportunity that we can also turn carbon dioxide into some valuable resources. So overall, I'm trying to address the environmental problems with keeping in mind that every crisis has an opportunity lying behind it. So as an environmental engineer or as a uh, citizen of responsibility, we should try to address that and try to turn the crisis into some kind of opportunity. So that's what I am doing right now, and that's the path of work that I'll be involved in the future as well. Over to you.
Thank you, sir, for your insights. Now, moving ahead to Dr. A.K. Keshri. Sir, we are eager to learn more about your work. Could you tell us about your field of study and the key research areas you are exploring?
Sure. Thank you very much. I hope I am audible to everybody.
Yes, sir.
Okay. Fine. Okay. You see, I first of all, I would like to thank all of you to invite me for this event. I am joining this event for the first time. So I may not be knowing that how you go about and what are the things we are supposed to do here. But anyway, um, I have been out of a station, so that's why I could not reply you in time. But just now I have come back, but I could join today, so that is a good thing. Now coming to my research interest on the areas, I primarily work in the water resources engineering. My expertise is something where we involve the hydrological and environmental modeling. I also make use of remote sensing and GIS for monitoring, mapping, analysis, and assessment, and the predictions. So if you look at different kind of the work what I have been doing, that basically involves the assessing the water resources under the climate change. In water resources, it includes both surface water and groundwater resources, how much that is available, how we can make the planning and management for the better utilization of the water, and what is going to be the implications of climate change on the water resources. And I also work in the area of environmental impact assessment of various projects. Either it could be, the industrial projects or any kind of the water resources projects like hydropower or any kind of the industry installation. What could be the environmental implications of this? What kind of the measures we should take, to control the pollution, and then how the contamination transport takes place in the groundwater system. That means if some leachate or if some kind of the wastewater is coming and reaching to the groundwater system, either it could be anthropogenic or it could be geogenic. So how that basically migrates from one place to the other place, what kind of the measures we should take to control the pollution, or to go for some kind of the remediation program. So that is what my core area of research. But I primarily work by making use of the numerical models and by making use of the satellite data, where we can derive many parameters using satellite remote sensing. So it includes mostly the image processing, uh, you know, and that helps me also to analyze the natural hazards like floods, droughts, and the snow and avalanches, like how the avalanches takes place, so whether the glaciers are receding or glaciers are enlarging, or what is going to be the futures of the glacier melt and how much that is going to contribute to the runoff. So these are the prime areas or basic areas you can say where I work. I'll be happy to answer any of the query you would like to have, or any kind of thing in interaction you would like to carry out right now. So thank you very much right now. That is all from my side. Over to you.
Thank you, sir. So before going much into the deeper sections, so now moving to Dr. R. Balasubramanian, sir. Sir, we are keen to know your area of study. So could you please tell us about your research area and its key aspects?
Is Professor Balasubramanian there?
Yes, ma'am.
Yes, he's definitely in. Why is he not responding?
There might be some network issue with Professor R. Balasubramanian, sir. So, so let's move ahead. So, like your fields of study are really captivating as of now, and we are eager to know more about how your research areas and how your fields of interest are in hand with the sustainability. So now let's start with you, ma'am, Dr. Sudha Goel, ma'am. So we are interested in exploring how your research area is in hand with the eco-friendly practices. So could you please drive us through that?
Okay, that's a good one. And the first thing that comes to mind is environmental risk assessment. I've been quite deeply involved with this subject area for more than 20 years now. And are you able to hear me clearly, or do I need to speak more loudly or
Yes,
something? It's
yes, ma'am,
fine.
you're clear.
Okay. Risk assessment is required. So what we are doing is mainly human health risk assessment. And as human beings, we are constantly exposed to all kinds of chemicals that are present in our environment. I already mentioned microplastics. They are particles. And particles as well as chemical compounds, both are basically present in every part of the environment. So today we are dealing with polluted air, water, soil, consumer products. They are everywhere. Okay. So in all cases, they are a problem for human health, and they're also a problem for ecosystems. So we need to make sure, remember, for sustainable development, we need to make sure that human health is not under stress. So that is our first commitment, that we are committed to public health. That is the first thing. And the second thing is that we want to ensure that our ecosystems will continue to thrive. So, given the fact that we have all these chemicals and particles that are present in the environment, they are causing all kinds of problems, and we need to address and we need to remediate these problems. That's a major issue that my research group is working on. I've already mentioned that many of the technologies that we're using, for example, chlorination has been around, it is necessary. It is one of the most difficult topics to handle because chlorination has helped human health to become what it is today. Today, the lifetime expectancy of any human being, at least in our country, is more than 70 years. And at the time of independence, I think it was around 30 or 35 years, something like that. Okay. So this improvement comes with improvement in public health, in education, as well as infrastructure. Now, when there is all around improvement, and part of that improvement has to do with chlorination or disinfection of water, our drinking water. So, because our drinking water is now of better quality, it has definitely improved our general public health. Now, on the other side, we are finding that there are so many chemicals like disinfection, byproducts, microplastics. The list is endless, pesticides, herbicides. All these chemical compounds are also cancer causing agents. Some of them are mutagenic, some of them are cytotoxic, some of them are genotoxic. All kinds of problems come from exposure to these chemicals. So again, focusing on the water quality aspects as well as the environmental risk assessment part of it, we have to balance the use of different technologies that we are currently using, and we have to find that optimum, you can say, optimum region in which we can survive. Okay. So we need to chlorinate the water, but at the same time, we need to reduce our exposure to any chemicals that are detrimental to human health as well as ecosystems. Those are a few examples. I won't go too far. I think we should give a chance to the other guests as well.
Yes, ma'am. Your work is impactful. So let's moving ahead to to Dr. Sudipta. Sir, we are eager to understand how your work promotes a greener future. Can you explain how your research area contribute to creating a more environmentally sustainable world?
Right. All right. Thank you for the question. So we always talk about sustainable development, and when we try to look at the classical definition of sustainable development, it says that sustainable development is a development which meets the needs of the present without compromising the ability of the future generations to meet their own needs. And we are trying to follow, the classical definition in true sense. Um, as I told you, that I try to work on various areas where we can generate value from the waste material. Just giving a few examples, you just take the case of, let's say, municipal solid waste. Today, we are, in my opinion, we are just sitting on a ticking time bomb, which is going to get exploded very soon. And this time bomb is nothing but the problem of handling municipal solid waste. And as the population is rising, we are getting more and more urbanized society, and so are the need for having sustainable methods for tackling the municipal solid waste. Now, if you think about the municipal solid waste, the biggest challenge in our country is that we do not segregate our waste. Now, and although there is a push from the government that you make dry waste and wet waste, sukha kachra, sukha or gila, but uh, giving you a very practical view of it, although we talk about it a lot, but it doesn't really getting followed by us, even by the educated people. So leave aside those people who do not understand the downside of not following these things. Now, what we are trying here is that we are in IIT Roorkee, we have developed a process which is now in a, although in a lab scale, but we can work with almost non-segregated waste, I would say semi-segregated waste, and you just use, and we are using insects to clean that waste. Just giving you a small example, suppose you have, suppose you ate an apple today, but you have some remaining portion with you. Okay, and now if you throw it out in the open, what is going to happen, that it will eventually biodegrade, but it will take almost like 3 months to get degraded, because it's a solid material, and the bacteria which would degrade it, that will use extracellular enzymes and all to first hydrolyze it, turn into simple molecules, and then it can use these molecules as their own food, right? Now, so that's a solution, but it will take a long time, right? But a very simple solution is that you feed this remaining apple to a cow, you know, and this, and making this, within no time, the waste is disappeared, from your site, and the rest of the things are done by the intestinal system of the cow, which digest it and assimilate it. So that means, when we talk about degradation, I mean the treatment, we always talk about degradation, No, why not? We now start talking about consumption. So with this view, we are actually using a black soldier fly larva for eating up the biodegradable part or eatable part of the waste. You think about a municipal solid waste, which is made up of kitchen waste, food residues and all, along with something which is non-biodegradable. So now you use this insects, they will simply eat those things which they can eat, okay? And they eat at a very fast rate, and they try to digest it in their digestion system, and remaining is recyclables or inert material which now can be disposed of very easily. So this is the philosophy of the treatment, and why we are using that insects. What would that insects do? For us, yes, these insects are very peculiar in that sense that when they metamorphose into a fly, the fly doesn't take any food. It doesn't have any food, mouth part. So it has to rely on the protein and fat that they kind of they store in their body, and they live with this stored protein and fat for remaining 4 days of its life. So you can imagine that when it's a pupa, which is the state before it becomes a fly, it will be full of protein and fat. And there's every opportunity that we can utilize this protein and fat for for a feed for the poultry, or fish, or some other animal, which are taken up by human beings, after that. So you are actually using these insects to channelize the nutrient back into the back into the food cycle, and that's how you are uh, stopping this environment from carbon dioxide emission and other kind of emissions as well, methane and others. So this is what I say, that we are meeting the needs of the present. That is, that's the present need. And, we are not compromising, with the future. We are not allowing any carbon dioxide to go out, or we are not allowing, any methane to be generated from here. We know methane is a much more potent greenhouse gas than carbon dioxide. So that's one example, and we are doing n number of things like this, so that we can strike the sustainability, utilizing or valorization of the waste that we see around us. So there are examples like this, and we will probably I'll deliberate on that, before I mean the remaining, as this discussion will move forward. So over to you. I think Professor Balasubramanian is here, so we wish to hear from him.
Thank you, sir. Thank you for your beautiful insights. And now we are pleased to have Dr. Rajasekhar Balasubramanian sir with us today. Although he was having some connection issues, his demonstration and commitment to join the session, so he joined the session with us today. He is all the way from the Department of Civil and Environmental Engineering at the National University of Singapore. Being a distinguished researcher, his expertise includes environmental sustainability, climate change, and urban air quality. And he's also notably recognized by the United Nations for his contributions. Sir, like we would be very glad if you could briefly introduce more about your research areas and areas of study, sir.
Hello, everyone. Do you hear me?
Yes, sir. You sounds clear.
Very good. All right. Good evening. I'm really impressed that you are having this online event on a Sunday evening at 4 p.m. So that shows your commitment to sustainability. So I really commend your efforts. So having said that, so I would like to talk a few words about, say a few words about my research. And as the previous speaker mentioned before, sustainability is a complex issue, and it cuts across different sectors, almost all sectors you could think of, industrial sector, business sector, education sector, and so on and so forth. So sustainability is at the core of everything we do on a day-to-day basis. So for us to achieve sustainable development, we have to bring the global community together. So it's easier said than done. So the way we carry out our research is to look at global challenges. For example, climate change. So then we sort of figure out as to how we could address this problem through collective and collaborative efforts, and then propose solutions, and then do test bedding. So climate change, as you all know, it's a very complex, multifaceted problem. So we have currently about 8 billion people. So all the 8 billion people we have in the planet are guilty parties, because everything we do on a day-to-day basis involves consumption of energy. And if we continue to use fossil fuels, certainly it will continue to emit more and more carbon dioxide. So the way to address this problem is to go for decarbonization. So the question here is, how can we contribute to economic growth of different countries without having carbon emissions, without having any pollution that you could think of, including air pollution? So we look at the kind of relationship, the connectivity between climate change and all other global issues. To give an example, air pollution. So the causes of air pollution and climate change are the same. In both cases, the root cause of these two problems is the use of fossil fuels. So then we sort of quantify as to how much of air pollution we emit and how much of CO2 we emit at the same time as a result of using fossil fuels. So then it's important for us to explore the use of renewable energy. So we have different types of renewable energy, but they all differ in terms of their cost effectiveness, in terms of technical maturity, in terms of their intermittency, and again, in terms of their reliability. So then we try to assess all these issues together so that we can come up with the most readily available form of renewable energy that will be accessible to the country we live in, if not to the entire global community. And then you reduce the cost of production of renewable energy so that it will be accessible to the entire community we live in the country. So the sooner we switch to renewable energy, the better it will be, because we will stop emitting carbon dioxide. We will also stop contributing to air pollution. So the way to go about is to sort of propose a solution that we think is viable, at the same economically viable, and also accessible to the community. Then we sort of study the effectiveness of that particular form of renewable energy in a more controlled environment in the lab, and then we try to scale it up. So this is how we do our research in simple terms. Because the problem we are addressing now in terms of climate change, it's a gigaton problem on a global scale. And we are emitting about 40 billion tons of CO2 every year. And we have a budget to comply with. And the budget for us to comply with in terms of reducing global warming or capping it to be less than 2 degrees Celsius is 800 billion tons. So we only have less than 20 years. to sort of meet this budget. So we don't have much time. And so the sooner we propose the solution and the sooner we implement the solution, the better it will be. So that's in a nutshell, this is the kind of research we are doing, but I'll be happy to provide more details if you're interested. Am I with you?
Yes, sir.
Okay, good. Yeah. So to give an example again, let's say carbon dioxide, CO2 capture, right? To start with, what kind of materials can we develop to capture carbon dioxide from power plants, from industrial flue gases selectively? If you look at the composition of flue gas that comes out from a power plant, you don't have just carbon dioxide, you also have other pollutants. So the material should be selective enough to capture only carbon dioxide. That's one thing. And the second requirement is that, well, we also have water vapor. If you look at the flue gas, it's like the fumes coming out. So that clearly shows that we also have water vapor coming together with carbon dioxide. And this water vapor could also be captured by the material you are using for carbon capture. So that is going to be a competition between carbon dioxide and water vapor. So if water vapor gets captured by your material, then we have very little space. We have very little room for the capture of CO2, and the material is not effective. So we have to develop a material that can resist the uptake of water. So we are looking for hydrophobic material as an example. So the second requirement is that if you capture CO2, the material should be able to accumulate carbon dioxide as much as possible. At the same time, we should be able to desorb it. You sort of release it. You capture it and release carbon dioxide so that it can convert the captured carbon dioxide into other materials, industrial chemicals, industrial fuels, and so on. And here we are using carbon dioxide as a feedstock. So it's freely available up in the air. We capture carbon dioxide selectively. You accumulate it onto the surface. You dislodge it from the surface of the material, and then use carbon dioxide for further conversion into other useful value-added products, including fuels. So that's a tremendous challenge. First of all, to capture carbon dioxide selectively, it's important. And then we don't want to continue to use more materials. So the material we are using should be reusable. So if we can continue to reuse the same material again and again, you will be able to capture more and more CO2. So that will reduce the cost of carbon capture. And then you have to convert carbon dioxide into a particular product that you have in mind. For example, it could be methanol in the liquid phase. So methanol is a useful chemical. It's also a good solvent. It has number of purposes. It has number of applications. So if we can selectively convert carbon dioxide into methanol with very high yield, that's fantastic. So that's a tremendous challenge. So again, we don't want to absorb, you don't want to consume a lot of energy for this conversion process. So the way we go about doing our research is to develop a material that can absorb the visible light from the sun, which is free of cost. So if we can absorb the visible light coming from the sun and trigger the conversion of carbon dioxide into a product like methanol, is going to further reduce the cost of production of methanol, and again is renewable. So we are not emitting carbon dioxide in the process of making methanol. So it's carbon-free methanol production. So that's a kind of technical solution that we are looking for. And then we do it in the lab in a controlled environment. Then we put it on the roof of a building in order to capture CO2 from the air, and then figure out how much of the chemical that we can produce through engineering applications. So it's a matter of scaling up the process from what you do in the lab all the way to a city scale or a country scale. So that requires collaboration with experts coming from different disciplines. So that's a fascinating part of doing research in sustainability, because it's not up to one disciplinary expert to be able to solve this problem. It's not possible. So we have to have the inputs involving collaboration from different disciplinary experts, including social scientists and behavioral scientists. And sometimes we don't consider their role so much in the process of knowledge discovery. But according to my experience, social scientists and behavioral scientists play a very important role in the context of sustainability, because one of the problems we have at the moment is the unsustainable consumption of our limited resources, because we are very much focused on economic growth, which is being quantified in the form of GDP or per capita GDP, gross domestic product. So what we have come to realize now is that the gross domestic product, which is quite often cited by different countries as the real progress of the country, is highly questionable, because it comes with a price, and the price is global warming or climate change. So can we redefine GDP? And this is where a social scientist and a behavioral scientist play a very important role in changing the mindset of people so that we can consume less. So the key requirement in terms of achieving sustainable development is to be able to do more with less. So the key question now is, how can we do more as the population, human population, continues to grow with the less resources, particularly natural resources? So that completely changes the economic growth pattern. So we are switching to green economy or circular economy. So again, that requires collaboration with economists. So now if the way to look at it is that once you identify a problem and then propose a solution to achieve sustainable development, we have to start interacting with all other disciplinary groups. So in that regard, education plays a very, very important role. That's the reason why we are here this evening talking about the role of education in changing the mindset of people. So all of us play a very, very important role. So we have to do the road show. We have to conduct more such events like what you are organizing to reach out the community at large. And we had to convey the message to reduce the consumption of resources in simple terms that anybody can understand without using technical jargons. So this is the challenge that all of us have. So we have to learn from each other as to how we could engage our community at large, including decision makers and politicians who may not know so much about the current situation as we do based on our own research and the exposure we have by other means. So it's a matter of sharing knowledge and seeking collaboration and cooperation with the diverse communities we have around us. And having said that, if you are interested, I can share a brochure, send you a brochure. I have launched a new second major in my university. Is called Sustainable Urban Development. So it's a second major in Sustainable Urban Development that's open to all students across the campus with no prerequisites. So if students are interested in anything related to sustainable development, it's our obligation to educate them so that they can find better jobs than what they can get based on their own disciplinary expertise. be mechanical engineering, civil engineering, chemical engineering, whatever. That's a core expertise you have. But on top of that, it's important for all of us to be aware of the need to focus more on sustainable development. And hence, I'm offering this second major. And you don't have to do more courses than what you do otherwise. You can still graduate in 4 years. And so you can graduate in 4 years with the 2 degrees, 2 majors. The first major is something of your choice. And then you sort of you have an additional layer. And that is the second major that I'm talking about, sustainable urban development. And that requires interdisciplinary knowledge. So as the program director, I bring in experts from other disciplines and let them interact with our students. So that's the way to go, in my personal opinion. And so far, so good. But again, we have a quota, and the quota at the moment is 70 students for the program. But what I'm talking to, what I'm telling my management is not to put any restriction and try to increase the cohort size. But of course, we cannot do it overnight because of other constraints, and we do it in stages. And so we are going to be expanding to about 100 in the coming year, and so on.
Thank you, sir, for your enlightening response. We will discuss more as we delve into further discussion.
Thank you.
Let's get yes, sir.
So I will be online until 6 p.m. your time. Sorry, there was some technical glitch. I was not able to join you earlier, but I will continue to be available until the end of the event. Thank you.
Yeah, thank you, sir. So let's get back to questionnaire. Next, we have Dr. A K Keshari. Sir, how does your research contribute to the broader field of environmentally conscious water resource management?
Yes, thank you, Asika. You see, in general, the water, is needed by everyone. But, the way we behave or the way we manage the water, that becomes, not available to many of the people at large. Like, for example, if I'll tell you about even in the urban cities, like the city like Delhi, which is the capital of India, we have, the acute shortage of water even for drinking water. We have very skewed distributions in many post colonies. You may be getting the water around 450 LPCD, whereas the outer skirt of Delhi, they may not be, they are even deprived to get 40 LPCD. So think of, you have a skewed water distribution. This is one problem. The another what this kind of the problem gets aggravated because we don't have the water available. Either you talk about the surface water or the groundwater. If both of the waters are harvested or the extracted, then also we are not able to meet the water demand of the city. And the reason behind is, of course, the population is increasing. Secondly, what happens, the urbanization takes place at a very fast rate. So you have very change in the land use, land cover. And if you change the land use, land cover, that means you are changing the whole hydrological cycle. So your water cycle gets disturbed. It creates a problem of your water drainage. The stormwater dredge network gets choked. It brings out your urban flooding, which happens in many of the city. You might be noticing through the news. So cities are facing a big challenge of the water. So how you can sustain the city, how you can ensure the water sustainability in the city, that becomes a major challenge today. If you look at the rivers, in most of the rivers which are along the banks of or you can see, or along the banks of the river, if you see the big cities, they're also polluting. So you'll be having a lot of wastewater discharge coming to the river system. Although we have different regulations of controlling the industrial discharge, nowadays we have completely, ZLD, that is what we call zero liquid discharge. nothing should be discharged to the river. But in spite of having those regulations, you will find the infrastructure is quite less. Like if you think of the all Indian cities, if you include even in the metro cities, you don't have more than 60% of the infrastructure available in terms of the installed capacity of treating the sewage. So think of when the you are not able to treat the full capacity of the wastewater or the sewage water, that is what gets generated from the cities, what will happen? Those are somehow finding the pathway, either treated or partially treated to join to some river system. And then while joining to the river systems, it travels through the length of the course of the travel. It is going to allow also the leaking, or you can say the seepage to the groundwater system. So it contaminates also to the groundwater. So on one hand, you are not able to drain the water coming in the city because of the rain, because of the increased intensity of the rainfall, frequent peak intensity that is happening because of the climate change, which creates a choking of the drainage network in the city. On the other hand, you are also generating a lot of wastewater, which you are not able to handle. So the urban environment or the urban setup creates a big challenge for managing both the water. That means the fresh water for the drinking water supply to the people and the wastewater which we generate because of our own living style or the economic development. So if you look at the uh, trade-off between the environmental damages, or you can say the economic growth or the economic development. So these two, uh, how to find out the solution between these two. So that means the trade-off, if you see, then certainly that will tell you that you should go for the minimum environmental damages, but certainly your economic activity is going to be slowed down. So you will be having also economic development, and that creates a problem of the water pollution. And of course the air pollution also, but I'm not going to speak. You have another many learned speakers to speak on the air water quality, because air quality, I don't have expertise on air quality. So my prime focus remains on that how to make the city sustainable in terms of the water availability. Like in a city, you may be observing nowadays that people don't go for the horizontal expansions or the development, they go more for the verticals. The reason behind, because you don't have the land resources available to you. So you will be having 17-story, 20-story, 25-story buildings. But now, if you have met those kind of the vertical development, you also needing water. So the population is increasing. The number of people living in a particular cities goes on day by day. And then in addition to the fixed, the population who reside in the city, you have large number of the floating population who come from different areas, nearby areas, or you can say the satellite townships for work. So they will be migrating from here and there on a daily basis. And to cater the need of each and every people, you whatever the permanent fixed population you have and the floating population in terms of the drinking water or in terms of the municipal water use is going to be huge. And that is where we need to have some kind of the convergence between the environmental damages or environmental protection, or you can say the environmental management, and then whatever the economic drivers are there for the economic and socio-economic development. So that is where we come in between, and we try to see that how concretization is taking place, how that is going to affect the river systems in terms of the water quantity, in terms of the water pollution, either to the rivers water or to the groundwater system. So this is the one concern which makes sure that how the water can be made sustainable, how we can bring some kind of the smart water infrastructure which are capable of draining the water uh, during the peak intensity, which results because of the climate change of the frequent rainfall with a high intensity, but for a shorter duration, which creates a huge amount of the urban runoff. And then how we can, they take the measures to restore the groundwater system. That means we can control the diminishing groundwater level, how we can replenish those the aquifers. So that is the another concern remains in the urban setting, and we try to make some kind of the effort on this side. The another dimension, the associated with this, looking from the industrial development side, like a lot of industries nowadays are thriving on water, wastewater for their processing. So each, if you think of the any the industry, whether it is paper and pulp, company, or you can say the steel company, or even the electronics company. So all manufacturing plant all require water, depending upon what kind of they are producing, or whether they are producing steel, or they're producing tires, or whether they're producing paints, or whether they're producing sugar. So depending upon the type of the industry, each one requires a fixed amount of the water for producing their products. So nowadays, what we are doing, that we are bringing the concept of water neutrality, or we are bringing concept of the water footprint in the industry also. So we look at that what could be the specific water consumption for the process, or for the manufacturing. So like if you're talking about production of paper or production of steel, we may say that, okay, how much water you require per unit ton of the steel production, or how much water you require per unit ton of the production of the paper. So like that, for each of the industry, we work on that your specific water consumption for the fresh water should be coming very close to the benchmarks, or should be reducing year after year, so that your dependence on the fresh water, or your exploitation of fresh water remains, the at the low level, and then this is more is given for the drinking water. And then during the process, whatever the wastewater you are generating, at what percentage you are able to recycle that wastewater. So that means, are you using that water can be used in like the boilers, or in any other processing unit. So what we look at, what could be the interventions in the business process, either by changing some kind of the technology, or by doing some kind of the process management. So during in the whole supply chain of the product of a particular unit, how we can manage the water resources there. So that means reducing less the stress, or reducing the stress or burden on the freshwater resources, and increasing the recycling of the wastewater in the business process itself. We are not now are more impressed when the industry say that we are making use of the water for the horticulture purpose. So now that has gone. That is something it used to be suggested or advocated some time back, but now the things have changed. Everybody is much more aware. The people are making use of the treated wastewater for their horticulture or for the irrigation. But what we are looking at, that how much dependence of a particular industry is increasing on the wastewater and reducing on the fresh water. You will be surprised to note that there are many big industry in India itself who have gone to a great mile, extent to make use of the more than 50% of the wastewater in their recycling process, or dependence on the wastewater, treated wastewater itself. So their requirement from the fresh water has drastically reduced. And that is where we work upon that what could be the technological interventions, or the process interventions, or could be some kind of the operational interventions, which can reduce the water footprint, and it can bring to the either water neutrality or the water positive in the water shed where those industries are located. So this brings the second dimension of the water sustainability or water management, you can say. The third, what we look at, that because of the climate change implications, you know, the there are many disasters which you come across, which you see, like floods, or because of the less rainfall you get the droughts in many of the places, and the people face the problem of the food security, or the many farmers go on suicide, you know, because of the huge loss of their income. So the livelihood gets basically disturbed by that chain. And then because of this global emissions, you see that the temperature rises, and then you see the glaciers are shrinking, and then the high glacier melt brings the high runoff, and that brings the heavy flood also. Frequency of the flood event has gone up. The urban flooding event has gone up, but still at the same time, in the same year, you may be observing some of the areas which are having the drought affected. So we look at those situations also, that the how we can deal with, or we can do the interventions in managing that water resources, or predicting the flood in real time because of the change in the land use land cover, or because of the change in the rainfall pattern or the temperature rise. So that we take into the consider in a particular watershed or in a catchment, and we see or we go for advanced predictions in real time for the flood events, the glacier melts, or the glob situations, like you have seen the the disasters which happening in Uttarakhand, in Kedarnath, and then the hydropower stations get affected because of these those activity. Lot of infrastructures gets damaged because of those event, especially the flash flood, and the nowadays the glof is coming, which is happens because of the outburst of the glacier lakes. So we also work on those aspects, that how to develop a mathematical model which can not only bring us improved understanding about the processes, but also can help in devising some kind of the strategy or the interventions through which we can control them, or we can make the area the some kind of the adaptation strategies, you can say. So and then if you have a production before in hand, and then a lot of lives can be saved. Like you might have seen nowadays the frequent cyclones come, like in Odisha. We had the Amphan cyclone, but and that was having a big intensity, but the loss of life and property was very, very small. The life was to a very small, and the even the to the property, it was a very small losses. So it could be mitigated to a great extent. So primarily we think of through the the mathematical models and the data, historical data, whatever we have, and by making use of the climate change prediction models which run on the global scale by different general circulation models which are used worldwide. So our group or our team here look from the angle of water sustainability, and the creating some kind of the environmental sustainability in the industrial side, and taking the measures or taking the actions because of the implications of the climate change, and how the livelihood, how the water can be made sustainable, and then also the food and the energy could be secured. So the food energy, when I'm talking about food security, we are talking about the irrigation primarily, so that the irrigation water remains available for the growth of the crop. And then when we talk about the energy, then we are talking about the renewable energy in terms of the hydropower, not on the fossil fuel or nuclear or thermal power. My concern remains on the hydropower, which is one of the also the renewable energy, and how that can be secured without any problem through various schemes and through various management strategies. So that is how we try to address the water management and secure the sustainability in terms of the water environment. So that is from my side right now. Over to you. Thank you.
Thank you, sir, for providing us with the details. Now, let's invite our panelists to share their thoughts on the open-ended questions. These questions are for the panelists to respond to based on their expertise. Coming to our first question, can you place our spotlight on how technology has played a role in the advancement of sustainable development in your research? Anyone?
Yashika,
Sure.
can you
Yeah.
repeat your question?
Yeah, ma'am. The question was like to place a spotlight on how technology has played a role in the advancement of sustainable development in your research.
Okay, thanks.
All right. May I go first?
Sure, sir.
All right. So that's what we are trying to do here in our research group. We are trying to develop technologies to address the question of sustainability uh, in the development. Now, the previous speakers have told about various areas of research, and so there are requirement of policy-based decisions as well. But the policy, mathematical modeling, and everything taken in together. So we also need to have technologies to address the problems, right? So just giving, I told you about the example about how using insects can strike sustainability in terms of waste management. Uh, just giving you another uh, through biological means, uh, you have a secondary treated wastewater which contains phosphorus and nitrogen. Now, phosphorus and nitrogen, we know, is a nutrient which is very much required by the plants. In the agricultural sector, we had to import a lot of fertilizer from uh, various countries, urea and phosphate-based fertilizers. India is probably the largest importer of phosphate-based fertilizers. Now, think about we are treating wastewater in various places, in various cities, and this wastewater is kind of having phosphorus and nitrogen, which is a fertilizer to the agricultural field, and we can take it as a gift from the god actually. But what happens is that we do not have the confidence to use this treated wastewater to mix with irrigation water, to fortify the irrigation water with phosphorus and nitrogen, so that our dependence on the synthetic fertilizer is reduced. Because we are concerned about the health hazards that might be caused, when we try to use this water as for fortification of uh, agricultural water. Now, rather than recovering this nutrient, or rather than using this nutrient, what we are trying to do, we are trying the government as well as the policymakers are trying to push the technologies that develop a technology uh, for removal of phosphate and nitrate from the treated wastewater. So we are trying to add tertiary treatment systems to the existing wastewater treatment plants. And these tertiary treatment units, they will remove phosphorus and nitrogen, but at the cost of increased energy. You need a huge amount of energy for incorporating phosphorus and nitrogen removal. So don't you think that it is much better if we have something which will absorb or adsorb phosphorus and nitrogen from the treated wastewater and ferry this phosphorus and nitrogen to the agricultural fields. So what I'm talking about is to develop some kind of a nutrient or some kind of a biofertilizer which can be which can be prepared from the wastewater itself and can be delivered to the agricultural field. So keeping this in the mind, what we are trying to do here, we have developed a fertilizer, and this fertilizer is actually based on the base of this fertilizer is from agricultural waste material. So you think about agricultural waste, this is basically cellulosic and lignocellulosic material, and about air pollution caused in Delhi because of the burning of agricultural waste. It takes place every year. Every year there's a hue and cry that Delhi is in danger. So the burning takes place because they do not know what to do with this agricultural waste. There is no value associated with it. So if we can add value to this uh, some way or other, then we have this technology developed, then we can actually create or solve many problems that are associated with it. So keeping this in mind, what we are trying to do here is that we are developing a fertilizer which basically an adsorbent which is from this agricultural waste, and you take this adsorbent and put it in secondary treated wastewater. It soaks up all the phosphorus and nitrogen selectively from the treated wastewater, and when you dry it, it's a adsorbent loaded with phosphorus and nitrogen. Now this adsorbent is a bio-based adsorbent and it's biodegradable. It's cellulosic material and lignocellulosic material, which is not very readily biodegradable, but if you put it in soil, it takes some time, 3-4 months to get biodegraded. And now if you take this material and if you put it in the fertilizer field, then you will find that yes, in if you put it in the root zone of the plants, then it will slowly release this phosphorus and nitrogen, for the growth of the plants. Now, think about synthetic fertilizers that we use. Think about urea. Urea is very much soluble in water. So when you add this fertilizer in the field, what is going to happen is that it will be readily soluble with water, and 50%, maybe more than that, is getting lost through the runoff. It's not of any use. And when it is in runoff, it will go into the water bodies and create lots of problems like eutrophication in the lakes and so on and so forth. Now, ideal is that you use a fertilizer which will very slowly and steadily provide uh, nutrients to the plant as and when they will require it. Now if you we have tested this fertilizer and you add it once, and it will run through the whole crop cycle like 3 to 4 months, and it will continuously giving input of phosphorus and nitrogen to the roots of the plants, and you end up using less amount of fertilizer. So what you can see this example, you can see that we are trying to strike the sustainability in such a way that we are basically closing the loop, nutrient cycle loop. And the other speaker was talking about circular economy. That's a very good example of circular economy, that we are reutilizing our nutrients by closing the loop using technology. So that's what I mean to say. Here we have lots of people, here in this particular, as an audience. So, my appeal to the audience is that, you should come up with your own ideas, and you can imagine, you can find out that there is a lot of things that you can do, with this, and there is an enterprising opportunity for developing an enterprise or startup entrepreneurial activities around this. So don't think about startup is all about having just data science or things like this. You have ample opportunities to work in this area, waste management and sustainability, environmental sustainability and water. Uh, so, and you can do great things using technology. So, in an essence, as a sum up, what I want to say that, yes, advanced technologies are required to address the sustainability at this point of time, and also to address the newer problems that are coming in front of us. And there are enough opportunities for converting the crisis into something of not only environmental benefit but for enterprise growth as well. All right, over to you.
Thank you, sir. Thank you for mentioning. Ma'am, Sudha ma'am, we would like to have your perspective on this.
Was that for me?
Yes, ma'am.
Yeah. Okay. So I would add a few more points to whatever has been said. Um, the biggest technologies that we are encouraging everywhere at the national level, global level, these are all renewable energy technologies. Okay, so we are going for biodiesel, biofuels, biogases, a traditional method for being you can generate it from wastewater. We're going for solar, wind, water, tidal energy. So everyone everywhere is trying to increase the share of renewable energy technologies and reduce the use of fossil fuels. So our goal, especially in the context of sustainable development, climate change, is to achieve net zero emissions. So, as part of that, renewable energy remains the most important method for reducing carbon emissions. So, that is one thing that I can tell you. And we have been treating water, wastewater, composting. We are looking at both conventional as well as non conventional technologies. We are looking at the energy required for treating all these types of waste. Remember that there are two goals now. In wastewater treatment, we have zero liquid discharge. In solid waste management, we have zero waste to landfills. So we want to ensure that nothing is going as waste into the environment. So that whole idea of circular economy has been taken up in a big way. Okay, and part of that circular economy, we are now focusing on e-waste. So, e-waste, you want to extract as much useful material as possible from e-waste and recycle it. So, we have already seen recycling of paper, plastic, metal, glass, all that has been done and continues to be done. But we have a new waste stream. It's a huge waste stream which is increasing exponentially faster than anything else that is growing. And this is important, just like Dr. Sarkar said, it is important not just for the commercial value. You're extracting valuable resources. So it's important commercially as well as from the environmental point of view. Very often we think that, oh, if it is commercially viable, it must be bad for the environment. But all the examples that I'm giving to you, are win-win situations where they are commercially viable as well as good for the environment. So I'll stop at that point and over to one of the other panelists. Maybe Professor Keshari or Professor Balasekhar, Balasubramanian, I'm sorry.
Yeah, sure.
Sure.
Yeah. Well, I'd like to add a few more points to what Dr.
Okay.
Sarkar and Dr. Goel said about the importance of technology in sustainable development. Let me just cite an example. The most defining issue we have in this century, of course, is climate change. So initially we were talking about climate change mitigation, but now we have a new term called climate resilience. So that is getting a lot more attention than climate change mitigation. Let me tell you why. At the moment, our surface has warmed up by about 1.1 degree Celsius. Let's not forget the Paris Agreement, and that requires the global warming to be contained to be less than 1.5 degrees, if not at least 2 degrees Celsius. So at the moment, we are on course, to go beyond the threshold limit, 1.5 degrees Celsius, into the global warming. So initially mentioned about carbon capture and utilization. This is an example of one technology. So I don't want to talk more about it because we already discussed it before. The one that will be complementary to carbon capture and utilization is to reduce carbon emissions from the transportation sector. And as we all know, there's a rapid growth in the number of EVs, the EV vehicles that we have on road. So electric vehicles. But electric vehicles, of course, the price is rather high and then is going down rapidly now, which is a good sign. But having said that, the critical component of EVs is the use of lithium-ion batteries. So the most of the cost, is mainly due to the production and transportation across borders from one country to another, and consumption of batteries, lithium-ion batteries. So these batteries, of course, can last only for about 10 years. And the question now is, what do you do with spent batteries? And again, Dr. Goel mentioned something about e-waste. So this is an example of e-waste. And so can we sort of recycle lithium-ion batteries? And the reason why we are increasingly concerned about lithium-ion batteries is because we have a short supply of lithium. There are only few countries in the world that can supply lithium. And for example, China, Australia, Bolivia, and so on. So these countries basically dominate the global market in terms of production of lithium-ion batteries. So in the case of Singapore, as an example, we have very limited natural resources. At the same time, we made a commitment to phase out all fossil fuel cars by 2040, and we going towards electrification. But we may get into a situation where we may not have a continued or sustained supply of lithium-ion batteries. So this is where technology plays an important role. So once the batteries are used up, then we want to sort of extract valuable metals like lithium, cobalt, so that we can remanufacture lithium-ion batteries in Singapore, although we do not have natural resources. So having said that, what kind of technology can we utilize for recycling lithium, cobalt, and other valuable metals? So the past, people have been using pyrometallurgy or hydrometallurgy and so on. So all these recycling technologies are highly energy intensive, which Dr. Sarkar mentioned earlier about energy consumption. So we don't want to go in that route. So instead, we want to do microbial leaching, bio-leaching of lithium-ion batteries. So that's a kind of technology that we are using in our lab. trying to figure out as to how we could maximize the resource recovery, in particular lithium, cobalt, and other metals, and so on. So this is one aspect. There's climate change mitigation. Because we are not going to be very successful in mitigating carbon emissions despite the serious effort that we are putting globally, we had to be prepared for adaptation to the changing climate, which again requires some technology. For example, we may have an urban floods, like in a couple of weeks ago, it happened in Chennai, and we have massive floods. It happened in 2005, and again happened, this year, and a number of towns and within this city were affected. So the question now is, given the fact that the built environment is expanding with the population growth, we are losing the natural environment. So can we restore natural environment that we used to have prior to urbanization while built environment is still expanding? So that may appear to be more like a contradiction or competing goals to pursue, but it's possible to do it. So we are working on an initiative called Cities in Nature. So the whole idea here is to recreate natural landscape that we used to have prior to urbanization and still be able to solve problems of concern, including urban floods, and also the recovery or reuse of stormwater, which is otherwise dissipated into the ocean, right? Which we don't want to do that. So we are working on nature-based solutions in that regard. So with the use of nature-based solutions, we can tackle several issues that confront us in cities. For example, reutilization of stormwater for non-potable purposes without using technology with nature-based solution. In addition to that, we want to surround the buildings with the vegetation of diverse types that will contribute to biodiversity. At the same time, we can take advantage of natural ventilation rather than using air conditioning systems, which is going to be costing more money, and of course, it's going to be emitting more carbon dioxide in particular. So this is another example of a nature-based solution. So again, then the third component over here would be transformation. So we have climate change mitigation, climate change adaptation, and the third one is transformation. So basically, we have to have transformative change in our community. So we want to sort of encourage people to go for active mobility rather than using motorized cars. So for example, we want to redesign cities in such a way that our commuters feel encouraged to go cycling and walking rather than using motorized transport, even EVs, for example. So this is another kind of issue that we are focusing on. So for that to happen, there has to be some pull factors for people to go cycling. So again, by covering cities with vegetation, the cities will cool, and then people perception about cities will change as a result of the presence of vegetation of diverse types within cities. And naturally, people go cycling because they breathe cleaner air. At the same time, they're not emitting carbon dioxide anymore. And we also want to make the cities more friendly, easily accessible, to go to train stations by walking, and they can use public transport. So this is transformation. So basically, we bring three components together here under the umbrella of climate resilience, climate change mitigation, climate change adaptation, and transformative changes over here. So the bottom line is that whatever technology that we develop should be innovative, sustainable, cost-effective, replicable, and more importantly, scalable. So if not, we cannot achieve the goal in terms of contributing to sustainable development. Having said that, technology by itself cannot provide answers to questions we have about sustainability. We also have to get transformative change through policy developments so that non-technological approaches will turn out to be complementary to technological innovations.
Thank you, sir. Thank you very much.
you.
So as we are coming close to the end, we would like to have a photograph with you. So may I request Professor Sudha Goel to turn the camera on? Sir Balasubramanian, sir, like we would like to have a photograph. Thank you, sir.
Sorry, I didn't hear you.
So like we would like to have a photograph with you. So we just requested to turn the camera on.
Sure, yeah, it's turned on now. Do you see me now?
Thank you, sir. Yes, sir. Thank you, sir.
Good, good. Thank you.
So, thank you, sir. As we are coming close to the end, so let us take one question from the audience and then we'll wrap up. So I may request the audience to raise their hand, maintaining the decorum of the platform, and we'll get the access to post their questions.
Maybe everybody's tired. Oh, there's one question coming from Anuj.
Yeah. Anuj, can you please unmute yourself?
Hello, good evening, everyone. Yeah, sorry if any noise is coming from my side. I want to ask, given the dynamic nature of environmental challenges, how can the principles and solutions discussed today to be adapted to suit different geographical regions, or we can say cultural contexts?
Well, maybe I could answer this question. We have to have a multi-pronged approach to make that happen. And of course, knowledge creation is very important. That's why we are all working together to contribute to knowledge creation and, more importantly, dissemination of the knowledge we create, which is through publication. And the publication need not be through journal articles. It could be done by other means. And so basically we want to reach out to the global community through our outreach efforts. So if we can engage the global community and make a difference to the current practice, which involves unsustainable consumption and production of certain products that will contribute to profitability but not sustainability, and that will ring a bell. So basically requires collaborative and cooperative effort among the entire global community, for which education provides a platform through knowledge creation and dissemination.
Yeah, thank you very much, sir.
Thank you, sir. We may proceed further to Srinija.
Good evening, everyone. Am I audible?
Yeah, we can hear you.
Yes. So my question is, how can cities strike balance between urban development and maintaining air pollution?
Okay, that's a very good question. And so urban development certainly leads to air pollution, as you rightly pointed out. So the question now we are asking is like, can we contribute to development in a positive way without emitting any types of pollution, including air pollution? And again, we are talking about carbon dioxide as well. The answer is possible, but it requires a strong commitment and a strong political will. This is where the challenge is now. So again, as I pointed out, technologies by themselves may not provide answers to the questions we have about sustainability. So we have to go beyond technologies, for which we have to have cooperation with other disciplinary experts. And like I said before, about social sciences and also behavioral sciences and so on. So by having this kind of interdisciplinary collaboration and transdisciplinary interactions, with the NGOs and decision makers, policy makers, and so on, we can still contribute to development, for which again green economy plays a very, very important role. And these days, actually, we are not using per capita GDP as an indicator of the progress of a country or cities. Instead, we are looking at a different index called GPI, Genuine Progress Index. So that index considers GDP as part of the equation, but sustainable development is also playing an important role. So the answer to your question is sustainable development has to be incorporated in terms of the assessment of the progress of urban areas or cities, and not solely based on profitability.
Just to add, I think I'm AK Keshari this side. Just to add, the answer given by Professor Subramaniam, Balasubramaniam, that I would like to say that in addition to the technology, we also need to have, the policy in place by bringing some new policies that can also help in coping from the environmental problem. Just this example of air pollution, whatever you pointed out, just to give the answer with respect to that perspective or that question, like in Delhi, we had the policies of, the intermittent policies of not burning crackers, during Deepavali or during other festivals, like bringing the vehicular traffic, the vehicle on the road in the odd and even situation, the odd and even numbered vehicles only will ply on the roads, controlling, or you have seen the regulations by even the Supreme Court giving some kind of the order or directive to take the measures on reducing the burning of the crop residue, like subtle burning. So there are different measures, when that comes as a policy making, it reduces many environmental problems. Like these are the examples I just gave for air pollution. Similarly, for other kind of the material like use of the landfill material in the road construction, or use of fly ash, the product of the thermal power plants in the brick making. So there are many things which come on because of the changes in the policy. Nowadays, there is a significant work going on by Niti Aayog to bring the policy change in terms of the water neutrality. The CII, the Confederation of Indian Industries, they are charting out some kind of the blue rating on the lines of the the energy rating for the water. So the policy changes or policy also play a big role in addition to what you have from the technological interventions. Thank you. This is just I wanted to add. Sorry.
Thank you, sir. So, thank you all the esteemed panelists. As we wrap up the engaging panel discussion, let's take a moment to think about the valuable ideas shared by our wonderful panelists.
Yeah, I just want to take this opportunity to congratulate the organizing committee for organizing this important event that revolves around sustainability and sustainable development, and which is very, very important. And then it's a first step. And so keep up the good work, and your commitment to this initiative is highly commendable, because you are organizing this event on a Sunday evening at 4 p.m. Great, good job. Thank you.
Thank you, sir. So now we have traveled together to the landscape of wisdom filled with great thoughts and useful insights. Thank you, all the panelists. So now carry these gems with you and imagine the positive changes they can bring to your world. A big thank you to all the panelists. and cherished audience for joining us on this thoughtful journey. Thank you
Thanks
all.
for having me. Thanks for having me.
Thank you. Thank you very much. It has been a wonderful experience and wonderful sharing the knowledge with all of you. Thank you.
It was wonderful for us also, sir.
Thank you, sir.
Thank you.
All right.